going to go over how to make a door using a class blueprint. And then I'm going to come around and take a look at each of your homeworks. And then today, in addition to variables and simple math, I'm going to have you guys start the work and research on making Angry Birds. So I want you guys to design out a few levels for Angry Birds style levels. Hopefully you guys have played Angry Birds so you understand the gameplay of what's happening.
How similar does it have to be to Angry Birds? You're launching something and breaking stuff?
We're going to try to make it as close to Angry Birds as possible. I am not above making a direct clone of Angry Birds at this point, so we're trying to make an exact copy of it. So that's the goal, and that will be what your homework is tonight.
Could it be Angry Pigs?
It can be Angry Pigs.
And you're killing birds?
It can be any combination of pigs, birds, or farm animals that you'd like.
Vengeful pigs, that's what it's going to be called.
Okay, you got it. That's what it will be. Right, so last week I explained the difference between level blueprints and class blueprints. Just to reiterate, class blueprints here are things that you can reuse over and over again. Most of what you're going to make in this class will be class blueprints. The only cases where we're not going to be using class blueprints typically is going to be for matinees, so triggering matinees, so firing off something that plays in the level, or in some cases UI will be handled through the level blueprint as well. Specifically, like we're going to make a start screen, like a start game and a quit button screen that has like a splash screen that most games have, and that will be done through level blueprint. But everything else should be done through class blueprints. So this will be your starting point for almost everything. So I'm going to make a new door blueprint. And I'm going to dock this guy here. The first thing I'm going to do, one of the first things I like to do is add a scene. And adding a scene just makes it so that anything I add to the blueprint from now on, I can move and rotate and scale to whatever I want to be. So I'm going to add static mesh. It's going to be the door frame. And I'm going to add another static mesh. That's going to be the door itself. So for the door frame, I'm just going to pick the door frame mesh. And for the door, I'm just going to pick the door mesh. And the door mesh by itself is offset. So this is why I like to have it be the root. So either I can move the frame in position, or I can just move the door in position. So in this case, I'll just move the door. Set my scale down, crank down my camera speed here. Cool, looks pretty good. Notice that this door, the pivot is down here. So just like in the level blueprint, if all we can do is adjust the yaw value, so as we rotate this door, we can do this. If we can adjust the yaw value so that the door turns like this, then we'll have a working door. We'll put a trigger around it and we'll be done. So what am I doing right now? I'm adjusting the rotation of this door. And by adjusting the rotation of the door, it automatically adjusts the position of the door around the hinge, because that's what a pivot is. Right? So I'm going to have the door open like this. And this rotation here is going to be starting at 0, and we can move it around. So before I go any further, let me just place one of these guys in the level. Let's drag one of these guys here. Here's my door. Right? And I should take a minute. You guys are either artists and programmers, so hopefully you guys are aware of the idea of parent space versus world space. You guys have used that concept much at all? Anyone not familiar with it? Because I'll go over it if you're not. Parent space versus world space. Right. So this is important. This wasn't something that was ever like explained to me during when I was taking my programming classes, but this is something that is like supremely important to understand the difference. It's a pretty simple concept to get, though. What is the rotation of this door right now, the blueprint that I placed? 0, right? If I rotate the door 90 degrees, it's not a trick question. This door's rotation is 90 degrees, right? What about the actual door itself? So You can represent, we're just going to talk about rotation here. Rotation can either be described in terms of world space or in parent space. And world space is just, hey, relative to the entire world, what is the rotation of this blueprint? And in this case, it's 90 degrees, right? And if I clicked on the actual physical door part itself, there are two ways to describe the rotation of that too. All right, so the door with the actual doorknob on it, what is the rotation of that relative to the world? 90 degrees? What is the rotation of the door relative to the frame? 0, right? So if you're talking about rotation, if I say give me the rotation of something in world space, in this case it'll be 90 degrees. If I say give me the rotation of a door in parent space, the rotation of a door is 0. And specifically parent space is talking about the parent of the component here. So it's really the door in relation to its parent, which is shown here in the blueprint. So the door by itself has a rotation of 0 degrees right now. If I rotate this guy 45 degrees, that is relative to the root. That is in parent space rotation. What that also means is that this door now has rotated 45 degrees, but it's only rotated 45 degrees relative to the parent. And that's important because it makes it a lot easier to think about these things. What is the location of this door relative to its parent? It's 45 units in y relative to the parent. This is all important because when we go to rotate this guy, we can rotate this guy in either world space or in parent space. Unreal also calls parent space a relative rotation. So when you see anything that says relative rotation, it's relative to its parent. So knowing which one to use is an important distinction that you kind of have to make when you're dealing with any kind of transformations with your blueprints. So I'm going to rotate this guy from 0 to some 120 degrees, let's say. And when I rotate this part of the door, it's going to rotate the actual door, and that's placed in the level, no matter how or how I have this thing oriented, right? So if I have 4 of these doors, okay. So these two guys have different rotations, but if I rotate the door like so, they both open relative to the parent. So they both open 45 degrees relative to where they are. I mean, it makes sense. It's a door. That's just kind of how doors work. I mean, it's the same kind of concept in the world, right? There's nothing really, hopefully, that weird about this. Okay, so let's add a trigger on this guy. We need a box. And the box is going to be the trigger that represents where we interact with this thing. And I kind of want this thing to just encompass the front of the door. Like so. Okay. So there's our door trigger. And I'm going to compile, even though I have nothing really to do, but you can see there's a trigger on the door itself that's placed in the level. So what we want to do is set up behavior that when we overlap with this trigger, we're going to move the door over time. So I'm going to go to my blueprint, I'm going to click on my trigger, and I'm going to type overlap. Scroll up to the top, I'm going to add a begin overlap trigger event. And that's going to hook up into a timeline that I'm about to add that is going to be the door opening timeline. This is just like how we did it in the level. And then in here, I'm going to have this be the rotation. So the difference here is that when we did it in the level, we did all of our rotations in world space. We rotated the door relative to the world. In this case, using a class blueprint, it's much, much easier. We just have to rotate the door relative to the parent of the door. So what I'm going to do is I'm going to add a rotation track. And I'm going to have the door open over 3 seconds. I'm going to add 2 keys. The first key is going to be at 0 with a 0 degree rotation. The second key is going to be at 3 with a 120 degree rotation. I'm going to set it up to be an actual curve, and that's it for that. So I have 2 keys, and so when I start this timeline, it's going to go from 0 to 120 degrees. Along the Y, you can see that the value here. And that's what's going to spit out right here. So I'm going to grab the door on the left here, that's listed in my components view. I'm going to grab that door, and I'm going to drag a wire. I'm going to do set rotation. And here's what I was just talking about, world rotation and relative rotation, right? Which one do we want here in this case? We want relative here because we want to rotate the door relative to its parent, because we know that rotating the door in this view, if I click on the door and I rotate it 120 degrees, it'll rotate relative to the parent, which is the root here. Okay, so I just call update on that. The new rotation that I'm going to plug in, I'm going to adjust the yaw here. In order for me to plug in the yaw, you can't plug in the rotation into the yaw like here. You actually have to make a rotation first, and then you can plug in a yaw. And that's it. So that's the door that will open over this amount of time and then animate when I walk into it. What we can do is we can have the door close when you leave it as well. So I click on the trigger again and I type and overlap. And I just have to reverse it. Compile and play. Walk up to it. Even though the door has no collision. So you can do this to make a trapdoor as well. So yeah.
I kind of noticed that in the background, the blueprint was running. Like you can see the...
Yeah, when you walk into it?
Right, you kind of saw it. Well, I think it was when you left it, you can see the white arrow kind of...
I have to click on this guy here.
Okay. So you can debug from the blueprint?
Yeah, you can totally debug from the blueprint.
Okay.
And so what's nice is that you can actually view this thing here. You can view the rotation. If I slow this thing down, if I double click on this guy and make this guy last over 6 seconds, so this key will be at 6 seconds. And then I go here and I play. Now when I walk into this door, I can Alt-Tab, and I can view the rotation, the yaw, this guy here I want to see. Oh, he already opened. Damn it. This guy right here. I can't catch it in time. I gotta slow this down even more. 6 seconds. See the rotation going up?
Okay.
And you can also, if you care, you can put a breakpoint here if you want to stop it, stop execution at that specific point. So you can add a breakpoint, which means that whenever that thing runs or stops, it'll tell you that, and then you can step, and you can see more of what's happening. Yeah, if you step, notice I'm in the animation blueprint now. Stepping is only mildly useful. Okay, so let's make a trapdoor now. So what we can do is make another blueprint. I'm going to make a different one this time. I'm going to make a trapdoor. And I'm going to add a scene again. And I'm going to add a static mesh. This time I only need one. And this time I'm going to use a cube. And I'm going to kind of shrink it down so you can stand on it. And then I'm going to add a box to represent what the trapdoor shape should be. So any unfortunate soul that happens to walk on top of this will hit this trapdoor.
I thought that it was supposed to be 2 doors.
It can be. I mean, you can make it 2 doors, but
Oh, I thought it had to be.
I can make.
A whole other box of worms.
We can make it 2 doors. It's not really any different.
Well, because then there's the issue of the pivot.
Yeah.
And also the plugins for plugging in the blueprint. Because there's multiple inputs.
Yeah.
That's what I was running into.
Well, let me do it with 2 doors so I can show you how to do this. I'll shrink it down halfway. I want to make sure these things are scaled correctly. I'm just going to try to make it easy on myself and do 0.5, 0.1. This guy will be 0.5, 0.1. This guy will be -30. There we go. And what you,
At this moment, do they have collision on them that would interact with each other if it tried to like drop and?
They don't have interaction with each other, only with other actors and dynamic things. So,
Okay.
so what we can do, I'm just going to name this guy Trapdoor. Trapdoor 2. So, if I place this guy in the level, let me do a quick example of how this is going to work. So I'm going to place a trapdoor. I'm going to place 2 of them for now, just to prove how this works. If I were to rotate these 2 guys, and I wanted them to rotate along a pivot here, where is the pivot of this thing right now? It's in the center. If I want to adjust it so that the pivot is on any specific corner, well, what I can do is make it behave kind of like this, where I can have it rotate around another object. Right now, this thing is rotating around the pivot because that's where the root is. So if I could show you the root, it's actually in the center right here. So what I can do is I can make a new scene. Call this guy the pivot. And if I just parent the doors to that, and then what I can do is I can move these doors. So there's my pivot now. And notice when I rotate this guy, it's actually rotating around the pivot, right? Because the pivot is here, and the 2 meshes are attached to it on the side. So what I can do is take this pivot, oops, I didn't select the pivot. So there is my empty scene object. There's my empty scene object that is just acting as the parent to the trapdoors. Okay. So this guy, when I rotate him, when I rotate the pivot, it actually rotates both doors around its position. And I can make 2 pivots if I want them to rotate independently. So here's my second pivot. I'm going to move this guy over here. And then trapdoor number 2. Oops, he's actually in the right spot. Pivot number 1. So here's my first pivot. Here's my second pivot, right? So if I rotate these guys like that, right? You can see how that could be a trapdoor. You need to have done the relative rotation to understand, like, okay, I can rotate something relative to something else to understand the pivot. But it's cool. We can do this right now. So I have these guys. I'm just going to clear out their, I'm going to clear out their rotation for now. And what I want to do is, I'm actually going to take this pivot. So if his pitch goes to 90, he opens fully, right? If this guy's pitch on the pivot 1 goes to 90, or -90, then it goes to open as well. So we'll just set up the same thing we just did with the regular door. We're just going to use a timeline to control the rotation of this thing. So I'm going to clear that. Go over here, grab my box, which I'm going to rename to be trigger. Click on the trigger and do overlap. Okay. And I can do a timeline again. I'm gonna actually do 2 timelines now. Actually do 1 and then multiply the reverse. Open door. This guy here, I just want him to go, it's another rotation track. Again, this time I want to open in half a second because I want the trapdoor to be really fast. The first key is going to be at 0 and 0. The second key is going to be at 0 and 90. Oops, I did 0 and 90. Yeah, it should be 0.5 and 90, sorry. Might as well have it smoothly open. Okay, so there's my rotation. So if I go back to my components view, pivot 2, if I just set the rotation of the pitch to be 90, that works. So let's just do that first. So I grab pivot 2, drag him into the level, set relative rotation, break this guy off, make a rotation, and this time it's going to be the pitch because that's what I was rotating before. Okay. So here's my, let me cut out some BSP here. You're obviously going to be able to tell this is a trapdoor, hopefully.
Yeah, people will still hit it.
Yeah.
Throw grass next to the island,
I could throw some grass on top of it. I just want to take my subtractive brush here for a second and scale it down so it actually matches that thing. I don't know what the dimensions of that are. 100 seems pretty good.
Look at the blueprint and see what the actual dimensions are of that.
Yeah, I could, but just for the sake of time, I'm just going to do it like this because I don't necessarily care too much. I just want to make sure that there's a hole there. It looks like there's a treasure in there. So that's it. So one of them open, right?
It's a little small.
It's a little small.
It's a little small. Maybe I need to crank this guy up a little bit. All right, so let me scale him up. Oops, that was the wrong thing to scale up, this guy. There we go. And then I need to fix the subtractive brush here. This is why I like editing in orthogonal view because it's way, way easier. Let me turn off the snap scale. Okay.
I'm sure it just is in there too because it can get stuck.
Oh, really?
That's what happened to my elevator. It's like jacking up against the wall.
The Z fighting is kind of killing it right now, but we'll deal with it. It's fine for the sake of example. It's a little it's a cute little guy. Let me just go here and
It's a deadly trap. Maybe it turned out. I could have totally sprained his ankle.
okay. I just need to make it go all the way through. All right. Let's stop this for now. Go here. That's a little better. Okay, so then let's do the other door now. So that proved it. So I'm just going to set up the other pivot. So again, I could copy paste this thing here. The pivot's going to be the target. And remember though that this guy's pivot needs to be negative. This guy's pitch needs to be negative because when I go here, the first pivot, look at the yaw, or look at the pitch right here on the lower left as this opening. It goes from 0 to negative 90, right? So if I want to just negate that, I can take the rotation value here, I can multiply it. This is the first step into simple arithmetic that you'll need to know. Multiply a float times a float. Multiply this guy by -1 and then plug it in. Okay. So these are my 2 rotators for the trapdoor. No, this handles the one side of the door, the left side or right side, and this handles the other side. They both open at the same time. Oh yeah, good call. Thank you. You're totally right. Yeah, you have to plug those in. And then what I asked if you had time was to delay the opening. What the nice part is that you can do things like delay. Just put like a half-second delay, and then we're going to make a sound of a trapdoor opening. Like click. No, like the dreaded click sound. You know, when you step on a mine in movies, that kind of thing.
I know, it is, these sounds on this website are so
That's perfect. Yeah, that's the one. I use this site for making games. Like, it's just so fast, and it gives you really good. It's all like retro kind of chiptune-y sounds, but it works. You know, I don't think there's anything better out there. It was made specifically for the Ludum Dare competitions, which I think is cool. Okay, so I'm just gonna drag this guy right on top here because that's fine. And then what I'll do is right before the delay happens, we're going to play a sound. And the sound we're going to play is the hit hurt thing that we said. And the location, I want to play it at the trapdoor location. So I just do get actor location, and that'll play it at the location of this blueprint.
What was that website again?
bfxr.net. It's cool. Right, so that was it. Why don't I come around and take a look and see what you guys were able to do, and then we'll move on to the lecture after that.